Math 206 students, so we've done a few examples and went through a few theorems about parallel lines and transversals. So I'll go through one more here, which says basically that if you have two parallel lines, N and M, and that are cut by a transversal, say K, turns out that these two interior angles that are on the same side of the transversal happen to be supplementary. They add up to 180 degrees. So, i.e., interior and exterior angles on the same side of a transversal to parallel lines are supplementary. All right, and here is how that goes. First, we know that angle 1 here and angle 3 are congruent because they are corresponding angles. So angle 1 is congruent to angle 3 by corresponding angles. And we also know that angle 3 and angle 2 add up to 180 degrees because they are supplementary. So the measure of angle 3 plus the measure of angle 2 is 180 degrees by supplementary angles. Because this is a straight line, K is a straight line. So then because these two are congruent, I can substitute the measure of angle 1 in here for the measure of angle 3. So therefore, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So we know a whole bunch of things about all the angles made by two parallel lines and transversal. First, we know all pairs of corresponding angles are congruent. All pairs of alternate interior angles are congruent. All pairs of alternate exterior angles are congruent. We know that vertical angles are congruent. We also know now that interior angles on the same side of the transversal are supplementary. So these two add up to 180. These two add up to 180. Also, in exterior angles on the same side of a transversal, these two and these two are supplementary as well. All right, so let's use all that information and apply that to polygons. So first, the theorem that we had at the top of the last page was that the sum of the measures of the interior angles of a triangle is 180 degrees. So what about any other polygon shape that has, instead of 3 sides, what if it has n sides in general? So in order to illustrate this, what I'll do is draw myself a polygon. I'll just draw a hexagon as an example. And let me take this hexagon, so this is my example. This is a hexagon or a sixagon. It's got 6 sides. Whatever polygon you have can be broken up into a collection of triangles by picking any one of the vertices and connecting it to another vertex to create a diagonal in your polygon. So this was a hexagon. My hexagon can be broken into 4 distinct triangles. And it is always the case that an n-gon can be decomposed into, so if I had 6 sides here, that gives me 4 triangles. you can always have 2 less than the number of sides that you started out with. So when n is 6, this gives me 6 minus 2, which is 4. So it can be broken down into n minus 2 triangles. And it turns out that for each one of these triangles, these 3 angles add up to 180, these add up to 180, these add up to 180, and these add up to 180. So I have 4 groups of 180 degrees. So therefore, the angles in my polygon, so the interior angles in an n-gon add to n minus 2 times 180 degrees. So here's the formula for what's the sum of the measures of the interior angles of any convex polygon with n sides. Take the number of sides, subtract 2, and you have that many triangles, so that many groups of 180 degrees. All right, so with this information, we can actually figure out if you have a regular n-gon, you could figure out what each angle measure is. So first we have to remember, what does it mean for a polygon to be regular? It means that all angles are congruent and also that all sides are congruent. But we actually don't need that piece of information for this example. We just need that all angles are congruent. So let's start with an example. Let's imagine that we, again, have a hexagon. And imagine that I drew one that's actually regular, so that imagine that all these sides and all these angles are exactly the same. So in this example, it's a 6gon. The sum of the angles is 4 times 180 degrees, or in other words, 720 degrees. So altogether, you've got 720 degrees, and there are 1, 2, 3, 4, 5, 6 angles here. So each angle, because they're all the same, measures 720 divided by 6. And that will be 120 degrees. So in general, if you have an n-gon, n is your number of sides, each angle measure will be, you take the total angle measures for the sum of all of the interior angles. So that'll be n minus 2 times 180 degrees. But then we divide by however many angles there are, which is n. So n minus 2 times 180 over n. And that's our formula for each angle measure, but this only works if you have a regular n-gon, meaning that all of the angles are exactly the same measure. Okay. So this is for interior angles, but what about exterior angles? First, we need to imagine and remember what an exterior angle is. An exterior angle of a polygon is made by one side of the polygon and the extension of a contiguous side of that polygon. So here's the angle made by that extension in this side. So if you have here, I have a pentagon, 1, 2, 3, 5 sides. I have 5 interior angles and also 5 exterior angles. And there's a simple formula for what the sum of the measures of the exterior angles of a convex polygon is. And here's how you imagine that. Imagine yourself as a person who is walking along the sides of your polygon. And every time that you get to an angle, you turn to continue walking on the along the polygon. And at the end of the day, when you come back to where you started, the sum of all the angle measures is the total amount of turns that you had to take. So imagine you walk. Well, let's start right here. You walk along the side of your polygon, and then you have to turn by angle measure beta 1. Now you continue walking now along this line, and once you get to this vertex, you have to turn by angle measure beta 2. Then you continue walking and you turn by angle measure beta 3. Continue walking, turn by angle measure beta 4. And continue walking, turn by angle measure beta 5. And now you are back where you started in the original direction that you were facing. So, well, what happens when you make all those turns? You start out facing this direction, you turn, and you end up facing this direction. You made a 360-degree turn. All right, and that can also be seen if you imagine shrinking this shape so that you don't change the angles, but you shrink it so that the interior of your polygon becomes like nothing. You have angle beta 2 here coming out this direction. Here's angle beta 3, beta 4, beta 5, and here's again beta 1. So imagine, again, you took this polygon and you shrunk it without changing any of those angle measures. You'll end up with a 360-degree turn. Right? All right, so that one's pretty easy to remember. And it doesn't matter how many sides you have. Still, you will end up making a full 360-degree turn if you walk the edges of your polygon.